Okay, let's get back into it. So our next question is regarding geomorphology, and this question coming from Ishmael. Yes, and it's regarding river grading and rejuvenation. Now, excellent question, very popular question once again. Now, when we're going to look at this question, it's very important that you need to know your concepts regarding grading of rivers and rejuvenation, the definition regarding the image that's been given to us. Now, if we look at this image that's been given to us, figure 1.4, 1.5 represents river grading and rejuvenation. Now, before I want to continue, I need to explain, it's not in the question, but I want to explain to you, we need to talk about a graded profile and ungraded profiles. Okay, and rejuvenation is in the question, but before I'm going to have a look at it, let's quickly just have a look what's been given to us. Now, if you look at the image that's been given to us, the diagram, first of all, I see a river, it's meandering, okay, as you can see. The river is definitely meandering, so that's definitely a tip. And when that happens, we can say it's in the middle course of the river or in the lower course. Okay, very importantly, never happens in the upper course. Then we have a look, they've mentioned a nick point. Okay, a nick point, as you can see, situated right over there. It's like a nick. It's an uneven profile in the river in the river. And then we have the old floodplain. If we quickly want to define the floodplain, when it's rainy season, what happens? The volume of water increases, the water level rises, and the area situated next to the river usually be underwater. That's the floodplain. Okay. But now, as you can see, a new floodplain has been created after the nick point. Let me just wipe this off. After that little nick point that's situated over there, a new floodplain has been developed, and terrace-like slopes, which is a side profile, has been created because of this new floodplain. Then they talk about alluvium. I'll discuss that in the bit review, and then bedrock. Okay, but before I'm going to continue, let's just look at river grading. Okay, what's the difference between a graded river and an ungraded river? And I'm going to show you two longitudinal profiles of a river. Now, and I'll explain to you why it's so important. Now, when we look at a graded profile, it's a beautiful longitudinal profile. It's concave in shape. It's beautifully smooth. So when it's from the source to the mouth, okay, that's a beautiful graded profile, as you can see. There's no nick points. There's no unevenness in this profile. We say it's smooth and concave. In shape. Okay. So the source, by now you should know what's the source, where's the origins of the river. Okay. Source, and the mouth is eventually where it flows into an ocean or into a delta or a lake. Okay. But very importantly, when we look at a graded profile, we only experience permanent base level of erosion. Okay, permanent base level of erosion, that's obviously where the mouth is, right? Or we also refer to it as ultimate base level of erosion. Now, what is permanent base level of erosion, ultimate base level of erosion? It simply means the river can't erode any further than the mouth where it flows into the ocean. Okay, it's impossible. Can't. Okay. It's a graded profile. It's a very smooth concave shape from the source to the mouth, and we only experience permanent base level of erosion. But what's been given to us in this diagram is known as an ungraded profile, because what did we identify? We identify a nick point. So if we go back to our image, there's a nick point. Okay. And because of that nick point, we might be experiencing an ungraded profile, and I'm going to draw an ungraded profile. So this is almost like a plan view. I'm going to give you a longitudinal profile of that river that's been given to us. So ungraded profile, okay. Experience a nick point, like in our diagram above. Now, it's not a smooth profile like you can see with a graded profile. Just want to write down there, graded. Because of the nick point, because of the unevenness in the profile, okay, we refer to it as an ungraded profile. No, same. There's the source, there's the mouth. So what we have created with that nick point, we experienced a temporary base level of erosion. Okay. Now there's a temporary base level of erosion because obviously the nick point was created because of our next topic that we're going to discuss, rejuvenation. Okay. They've mentioned rejuvenation. I'll explain it to you now. But going back to our ungraded profile, the nick point has created a temporary base level of erosion. Our permanent base level of erosion is still at the mouth. Okay, keep that in mind. Now, I've explained the graded side of it, the river grading. Now, what we experienced over here was an ungraded river. The simple reason because we identified a nick point. Okay, and that nick point is there because of rejuvenation. Now, the best way to explain rejuvenation to you, think of your teachers. How do us teachers rejuvenate ourselves? Coffee, caffeine, okay, Red Bulls. You rejuvenate yourself, you try to get more energy. Okay, so what does rejuvenation mean? It means, how does river rejuvenation, what's the concept of it? It's when a river gains more energy, okay? So when a river gains more energy, what happens? A lot of things happens, right? Is erosive capabilities increase, okay? It means it's got more power. The river has rejuvenated itself. That's what it means. When a river rejuvenates, it's when a river gains more energy, okay? Like a teacher, like I said, we need coffee, sometimes Red Bull. But how does a river rejuvenate itself? Now that's our next question. Now, it's very simple. We add more water, we increase the volume, we add more rainfall, or we can look at stream piracy. Okay, I think it was a couple of weeks ago we discussed stream piracy, river capture, when one river steals the water from another river. Okay, but let's go and have a look at the questions. And Ishmael, let's go and answer these questions for you. Explain the term river rejuvenation. I've just explained it to you. When a river regains energy or more energy. Okay. It's like that Red Bull ad. Red Bull gives you wings. All of a sudden you got more energy. Okay. Now, state 2 points of evidence suggesting that river rejuvenation has occurred. Very simple. Okay. First of all, there's a nick point. Okay. As you can see, how does nick points fall? What creates unevenness in the profile? Erosion. Okay. A beautiful example of a nick point in the upper course of a river is a waterfall. Now, what happens with a waterfall? It's usually erosion taking place or rapids taking place. But in this case, what happens over here? We can see this river is in the middle or lower course. Why? Because it's meandering, okay, as you can see. So let's assume it was in the middle course. What caused 2 points of evidence? Now, first of all, the nick point. We can identify the nick point. The second reason is the new floodplain that's been created, okay. Now, how did the new floodplain occur? Very simple. we've added more water. Now, keep this in mind. If this was the river bed, now what happens when we add more water to this river bed? It's going to increase the erosional capabilities of the river. So what's going to happen? We're going to experience more lateral erosion and we're going to experience more vertical erosion. So what has happened in this diagram over here? More water has been added to this river, more erosional capabilities. So the river has become wider and has become deeper, as you can see over there, because it's created a new floodplain. Now, 1.5.3, draw a long profile of the river in figure 1.5 and label the profile. Now, that's exactly what I explained over there. It's not a graded river anymore because we have the ungraded profile. There's a nick point, there's a new floodplain. Now, this question, 1.5.3, draw a long profile of the river in figure 1.5 and label the profile. This is the graded profile. So the one that you're going to draw is this exact longitudinal profile. You're going to draw the river from its source to this mouth. The nick point creates a temporary base level of erosion, right? So it creates a nick point, permanent base level stays on the bottom at the mouth. Okay, so that's going to be your answer for question 1.5.3. That exact same diagram. Okay, brilliant, isn't it? By just looking at our previous figure. Now 1.5.4, provide two possible reasons why rejuvenation has occurred in this landscape. Now, I've mentioned it very earlier. It might be because of river capture. This river stole water from another river. Okay, so when you steal water, what happens? You increase the volume. So it means more erosional capabilities. Okay, what else might have happened? A dam is maybe it might be constructed. Okay, it can create that nick point. We don't know. It's not mentioned in there, but it can create it. Okay, another reason for it is because of more rainfall. Okay, so or we can say that the gradient has become steeper. Okay, because what happens when the gradient becomes steeper? The water flows faster, creating more erosional capabilities. Okay, so the correct answer for 1.5.4, why rejuvenation has occurred, more rainfall, we can mention that over there. You can say river capture. Okay, and isostasy, steepness increased. Okay. Now, if you quickly have a look at question 1.5.5, describe the formation of floodplains and the importance of humans. Now, I've mentioned to you over here, I will discuss this with you. Now, this is the floodplain. Now, first of all, it's quite important for us not to go and live there. That's probably the biggest mistakes people can make. Okay, for instance, if you look at townships, people next to the Alexandra River, they tend to build their houses on the floodplain. Biggest mistake ever. Even though the river might for a couple of years not increase in volume because of less rainfall or because of consumption, that floodplain is there for a reason, because when the river do go into flood, that area next to the river becomes flooded. And unfortunately, many people do not follow rules and regulations and they go and build their houses over there and might put their lives at risk. But why is these floodplains so important? Because when the river is in flood, remember, the load of the river is increased. Okay, when I'm talking about load, I'm talking about the eroded material. Now, what happens on these floodplains that are being deposited? I'm talking about silt. I'm talking about nutrients. Okay. Now, as you can see, alluvium, vitally important because these areas are suitable for farming. Okay, because it's got lots of fertile soil. So especially for farmers, it's vitally important because there's much nutrition for their type of plants they're farming. Another reason why is these floodplains might add to irrigation purposes as well. Okay. Guys, unfortunately, we run out of time. We still got questions left. Hopefully, we can continue with it next week. Do me a favor, send these questions in Facebook. Just use your camera phone. Just take a photo, send it to us, and we will answer the questions, right? I hope you guys have an excellent week. Please do stay safe. Please revise and get these questions in. Have a good one. Cheers.